In this paper we investigate the issue of sensitive information leakage to third-party voice applications in voice assistant ecosystems. We focus specifically on leakage of sensitive information via the conversational interface of Google Actions and Alexa skills. Our work augments prior work in this area to consider not only specific categories of personal data, but also other types of potentially sensitive information that may be disclosed in voice-based interactions with third-party voice applications. There has been increasing concern of threats to users' privacy from third-party voice applications that are available within voice assistant ecosystems such as Google Assistant and Amazon Alexa. The porous nature of the conversational interface poses a potential threat to privacy in the context of third-party voice applications in particular. In current voice assistant architectures, the back-end code of third-party voice applications may be hosted on developer-owned servers that are not under the control of the core voice assistant provider, representing a risk of information leakage to external servers. Research has shown that users of voice assistants are not always aware that they are interacting with a third-party developer, as opposed to the core voice assistant provider. To investigate actual instances of sensitive information leakage in third-party voice applications, we implement a testing infrastructure that uses automated natural language interaction to mimic users' voice interactions with third-party voice applications. Our testing infrastructure uses a chatbot that interacts with Google Actions and Alexa skills via the client agents for Google Assistant and Amazon Alexa. Our chatbot is designed to recognize and respond to requests for specific types of personal data. We found several instances of informal requests for personal data via the conversational interface of Actions and Skills, highlighting the potential for developers to harvest personal data via this interface for purposes other than the one stated within the interaction with a user. Apart from requests for specific types of personal data, our chatbot is also designed to recognize and respond to various generic outputs from third-party voice applications, such as requests to make a selection. From our chatbot's interactions with Actions and Skills, we identified a number of interactions that, whilst not including a request for a specific type of personal data, might nonetheless be considered sensitive. In such instances, the sensitivity of interactions with a third-party voice application might depend not on the outputs from the application, but on the responses of users to the output. For example, if in response to a question such as that from the Waifu AI action of "How do you feel when you say that?" a user provides a generic answer such as "okay" or "fine," their interaction with the action might not be considered sensitive. However, if the user replies with a detailed account of their emotional state, it might be considered sensitive. We propose a restructuring of architectures for third-party voice applications based on the concept of digital ephemerality. This concept has also been developed in the context of ephemeral human-to-human messaging apps such as Snapchat, which claim to store no record of communications via the app. Digital ephemerality might seem especially appropriate as a privacy measure for the context of third-party voice applications, in mimicking the ephemeral nature of real-world spoken communications between humans. In a voice assistant architecture that implements digital ephemerality, the back-end code of third-party voice applications might be hosted on servers controlled by a trusted third-party security provider, rather than by the developer. This would enable transcripts of conversations between users and third-party voice applications to be deleted after every interaction, with the developer of the application never having been given access to these.